Alright, so we're going to compute a limit again. What we want to do with this, every time we look at a limit, first of all, we're describing the behavior of a function near a value. So if you're not picturing this in your mind, you're doing the limits wrong. It's not just some algebraic expression where we can write equals, equals, equals and get a number all the time. Like in some of the first videos, yes, if we can algebraically simplify, then we'll get a number. But this one, I can sort of see with some experience that nothing is going to help me with this. The bottom is already factored. The top isn't quite factored, but when I factor x out, that's not going to help me any. So the jig is up. It's either going to blow up positive or it's going to blow up negative, which means the limit, we're going to call this one-sided limit equal to positive infinity or negative infinity. We'll deal with when the positive is gone in one of the other videos below. So basically, because I'm approaching 3 from above, what that's really saying is I got 3 right here, and we're going to approach, x is going to approach from above. And what I want to know is my function blowing up or getting arbitrarily large positive, or is it getting arbitrarily large negative near 3 is what we're asking in this limit, because that's what's going to happen and we don't know which one. So all we really want is, we factored into its linear factors. We try to find out near 3 but above 3. I can get an inequality from that, so this is actually the most important statement at first. Near 3 but above 3, that says x is larger than 3, and now all of a sudden I've got an inequality. So what I want to do with that is check the overall sign of everybody else in this expression, the linear factors ideally. So what I want to do with that is write my limit as x approaches 3 from above. I can factor this out, x and x plus 5 over 3 minus x. Now, near 3 but above 3, I see that x is larger than 3, so that if I subtract x from both sides, 3 minus x is less than 0. So this guy, this piece, is negative. Now I have to ask myself the other two guys. This is hard at first for your brain to understand, but here's 0 way over there, and then I have 3, and I'm coming to 3 from above. So near 3 but above 3, x itself is definitely a positive number. And if x is definitely a positive number, adding 5 to that is not going to ruin its positive or negativeness, or its positivity. So x plus 5 is also greater than 0, near 3 but above 3. And then we also found from the inequality using the statement that 3 minus x is actually less than 0, near 3 but above 3. So then what I do is the same thing. I look at all the pieces that I have. I have 3 linear pieces. This one was positive, this one was positive, and this one was negative. So depending on how your instructor does this, they'll do it slightly different ways, but this is a lie anyways. I'm not going to write equals infinity. I probably will, but what we're saying here is that using these 3 conditions, we now have that this is equal to a positive times a positive over a negative, which means that this approaches negative infinity. I knew it was either going to be positive infinity or negative infinity, so now you can see it. And this is why students start really disliking these ones that don't exist versus the ones where we simplify and you cancel the x minus 3 over x minus 3 and we get a number. These ones are saying it's blowing up. We want to know whether it was blowing up down or blowing up arbitrarily. So what that told us was we had the picture of at negative 3 our function is getting arbitrarily large negative near 3 but above 3.